All right, so our first, before we talk about doing some other stuff here, let's first of all ask ourselves, is there a way, because really we've talked about conservative vector fields, but we didn't really talk about how we could tell if a vector field is conservative, and it's actually fairly easily done. Let's say I've got, in this case, we're just going to deal with, it gets a little more complicated if you have a three-part vector field, three-component vector field. We're just going to deal on the two-component vector field, I and j components, vectors. So a vector field is, there's a theorem, f is conservative if oh, I better say this. Better say it this way. There's a couple other things. Is a vector field on an open, simply connected region D? So what does that mean? Open, boundary points don't have to be concluded. Simply connected, there's no holes in your region. Then, if I'll say it this way, then f is conservative if P and Q have continuous partial derivatives and here's the kicker here, the partial of P with respect to Y equals the partial of Q with respect to X. So the partial of this one with respect to Y, partial of P with respect to Y, so the I components function, if you will, equals the partial of Q with respect to X. That makes it conservative. All right, so let's determine if conservative. Number one, f of xy equals x squared minus yx, I, plus y squared minus xy, j. So here we've got P is the first one, Q is the second one. So to determine if it's conservative, we just do the respective partial derivative. So P, we do the partial with respect to Y. So what is the partial of P with respect to Y? So the X, we do partial with respect to Y, the X is a constant, tree is a constant. So the derivative of that would be 0. The derivative of that would be, what, minus X? So it's minus X. Partial of Q with respect to X is the other partial derivative that we do for this. So the partial of Q with respect to X, well again, we're doing it with respect to X, so the Y is constant, so the derivative of that would be 0, and then the derivative of that would be minus Y. Those aren't equal. So what does that tell me? F is not conservative. For it to be conservative, these two things have to be exactly the same. So like I said, it's a fairly easy check. Just have to do a couple of partial derivatives. All right, so number 2, f of xy equals 2x e to the xy plus x squared y e to the xy I. Then we have the j component would be x cubed e to the xy plus 2y. That's j. The question is that conservative? What are the partials here for that? Well, partial of p with respect to y. That's the first one. So our p here is the I component. So what's the partial of that with respect to y? Looks bad, but it isn't so bad. Again, the x is held fixed, so it's like a constant. 2x is just kind of the coefficient, if you will. And then e to the xy, well, e to the x or e to the y is e to the y. So this has e to the xy. So the derivative would be e to the xy. And then chain rule would kick in. The derivative of the power with respect to y. Be x, right? Everybody okay on that? Plus, then the other part, we're doing partial with respect to y, so we got a little product there, so a little product rule. The derivative of y would just be 1, so this would be x squared times 1 e to the xy. Plus, then do the derivative of e to the xy, so it'll be x squared y times the derivative of e to the xy, well, that's what we just did, it'd be e to the xy times x. To simplify, 2x squared e to the xy plus x squared e to the xy plus x cubed y e to the xy. That's the p with respect to y. We good? Did I do that right? Oh, even simpler, okay? These are like terms. 3x squared e to the xy plus x cubed y e to the xy. All right. Yeah. So that's my derivative of p that I need. Well, to be conservative, then the partial of q with respect to x should be the same. Let's see. So here's q. So what's its partial with respect to x? Well, the second one's easy, but the first one, we got the product rule, don't we? Because we're doing the x's. So the derivative of x cubed would be 3x squared e to the xy. And then do the other one, the derivative of e to the xy, so the x cubed times the derivative of e to the xy, which would be e to the xy. And we're doing the partial with respect to x, so the derivative of the power would be y. So that would be the derivative of the first. Like I said, the second part of that's easy because we're doing the partial with respect to x. That's nothing. That's 0 because the y is fixed. It's considered to be fixed. Hey, look at that. A whole lot easier derivative, partial derivative there, but with the same, aren't they? Exact same. So this is conservative. Those are the same, so F is conservative. Like I said, it's not terribly difficult to determine whether a vector field is conservative or not. Just have to look at those respective partial derivatives. Is that okay? Any question or concern?